Okay, so now we're going to look at one of the first applications of finding the derivative. Okay, so we know that the derivative represents the slope at a particular point. Okay, so when we look at this first question, find the gradient of the tangent to y equals x squared when x equals 2. So if we think about this, it's good to picture some of these things really. We've got our original function here of y equals x squared. Okay, and what we're wanting is that when x is 2, what is the slope of the tangent at that point? Now, we should already know that the tangent will have to be positive because it's increasing in slope. Okay, going from left to right, this is a positive straight line. Eventually, you will actually be asked to find the equation of that tangent. Okay, and we need to find the equation of a straight line, you need the slope and a point. Now, to find the slope, that will be the derivative. So you can see where this is, well, hopefully, you can see where this is going to be progressing. Anyway, let's get back into the nitty-gritty. So let's find the gradient of the tangent now. We do the same thing using our rules before. Okay, so now dy by dx, if you want to write f dashed of x, that's okay too. Dy by dx equals 2x. And instead of leaving it like that, we're now going to say, well, when x equals 2, let's sub. So therefore, dy by dx, sub that in, 2 times 2 is 4. And you can see, well, it's positive, so that makes sense, and it will be pretty steep. If we ask to find the equation of the slope when x is, let's say, not going to be to scale really, so let's say 3, so maybe up here, what's going to happen? The slope is going to get even steeper. And you can imagine this is now my slope function. When x is now 3, 2 times 3 is 6. So it makes sense that it gets even steeper. If you wanted to know what it is on the negative side, okay, so let's say when x is minus 3, you sub that in. Well, 2 times minus 3 is minus 6. And again, that means it's a negative slope. So makes the sense. This is one of the reasons we love calculus. Makes sense. Okay, keep going. We've got this one again. We're just going to work from left to right. Dy by dx. Okay, 3x squared minus, this is x to the 1, so 1 times 5 is minus 5. And then technically you're taking away 1, so it's 0, and anything to the power of 0 is 1. So nothing is there, it's just the 5. Leave it as 5. Now we want it when x is, right? We want our x value. They're trying to confuse you by giving you 2 numbers. We just want the x. So dy by dx will equal 3 times 3 squared, take 5. 9 3s are 27, take 5, 22. So very steep function there. All right. As you're doing a lot of these, because the questions will start getting a little bit more complicated, these are hard too. In a test, I would like to think that we're going to have part calculator, non-calculator, but if you've got access to your graphics calculator, right, pull those up and let's just have a look at how you can check your answer a couple of ways using your graphics calculator. So the first one that we're going to do, we're going to go into our normal run mode, so number 1. And we want to find our option button. So to the right of shift, we press it. Then F4, the calc. And looky. We've actually got a dy by dx or d by dx, okay? We're going to press that. And we will type in our original function. So in our case, it's x squared. And then you can see down the bottom, what value do we want? In our case, it's 2. And we press enter. Confirmed, 4. We now go over and do the other one. So let's see how we can get that again. Right, remember you go option, we go calc, we d by dx, and pop in your function. Remember, press your arrow key here to get out of maths type, out of the upstairs bit, +2, and then over you go, pop in your 3, press enter, we are correct. Okay, while we're here and we've got our graphics calculator out, let's just show you the second way to use your graphics calculator. Let's go into our graphing mode. I'm going to pop in our function x squared. Before I graph, let's just have our standard. There we go, looks good. Now, I'm just going to move that up actually. Can I ask you to do one thing? I want you to go into the setup. So we're going to go shift setup. And we're going to go all the way down here. And can you see how we've got derivative off? We're going to turn that on. And then just press exit. So now we'll draw. I'm going to go to sketch. So it's in yellow. So we're going to go shift sketch. And look at that, tangent. I will press that. Nothing much happens because you're not telling it a point yet. So at the moment it's saying when the derivative is 0, when x is 0, but I don't want it to be 0. I want my x value to be 2. So I'm going to pop 2 in there, press enter, and look at that, dy by dx equals 4. And you can actually see it, and that's really good. If you press enter again, it gives you the equation of the tangent, and that's something that you will use a little bit later on. But I find that's really good. Okay, now to get out of that, press exit, draw. Oh, it still comes up. So if you go in, select, deselect, and draw, it's disappeared. So how did we do that again? Shift, sketch, tangent, at x equals 2, the point that you want. In fact, I can show you the other one. So what did we say before? What if it was just 1? So if x is 1, I'd expect my derivative to then be 2. Press that. Huzzah, it's 2. Okay. All right, let's check our other one. What was our other one? So we'll pop in x to the 3. One of the issues doing it like this is that you need to actually have the correct scale so you can see your graph. And in this case, that's pretty good. So again, we go to shift sketch, tangent, and we want it when x is 3. Before I press enter, remember we knew that it was going to be pretty steep. Just get out of that. Select, select. So whereabouts is 3 over here? So we've got 1, we've got 2, 3 is sort of up here. So it's going to be a little bit high, and you can see it's going to be very, very steep. I'm just going to see if that will actually 1, 2, 3. Okay, so shift, sketch, tangent when x is 3, enter. Yep, and very, very steep. You can see whereabouts it is. So try and keep in mind what your derivative is actually representing. Okay, it's the gradient of a tangent at a particular point on a curve, instantaneous rate of change. So play around with that. Hopefully that helps you. With the rest of that exercise, you're using the skills that we used previously. So when you have a fraction, simplify it first. Okay, so remember with ones like this, what you want to do is actually divide through by the x squared first, so simplify. So x cubed divided by x squared, dividing by the same base, take the powers, so that's going to be x, minus 4x, oops, just pop that, that's technically a 1. So 1 take 2 is minus 1, and then that's going to be minus 8, x to the minus 2. So now we're going to differentiate, because that was still just y equals, all you were doing was simplifying. Now differentiate, so 1 minus 1 times minus 4 is positive 4, x to the minus 2, minus 2 times minus 8 is plus 16. Now it's going to be x to the minus 3, okay? When you're popping minus 1 in, that's pretty easy. Personally, I find if use your calculator again to sub it in. Sometimes for me, I find it's easier if I simplify by putting the powers downstairs. And now when I substitute in for x equals minus 1, okay, we end up with dy by dx. 1 plus, now minus 1 squared is still 1, so 4 divided by 1 is 4. And minus 1 cubed is minus 1. 16 divided by minus 1 is minus 16. Okay, so 5 take minus 16, we get minus 11. Now if I wanted to check that using my calculator, my preference would not be to be in the graphing mode, okay? The graphing mode helps you if you're trying to find the equation. You can check it there. I would go back to main menu, okay? And do we remember how we get our, what's going on there? Our function up. We will go option, calc, put in our derivative. You can actually put in the fraction. You don't even have to simplify it. It's that good. This is when your calculators start really earning their money, the amount that you paid for them. Okay, x squared, and then all the way over, oops, went too far, -1, and huzzah, -11, so we know that we're right. So mess around, play with that calculator, and hopefully that has helped you.